Hello everyone, this is Atharva Gaikwad and today in this video we will be seeing some basic information about the sliding base isolation system which is used for the design of earthquake resistant structures to withstand the earthquake forces during an earthquake. Let us see what is base isolation system first. It is a system that may be defined as a flexible or sliding interface positioned between the structure and its foundation for the purpose of decoupling the horizontal motions of the ground and the horizontal motions of the structure, thereby reducing the earthquake damage to the structure and its contents. So basically, base isolation system absorbs and deflects the energy released from an earthquake before it is transferred to the structure. So in this figure, you can see that a general representation of an base isolation system, where you can see that the foundation is partially separated from the superstructure from these dampers or the base isolators. So let us see the working principle of a sliding base isolation system. The first is flexible bearings. The foundation of the structure is supported by flexible bearings, which are designed to allow the horizontal movement. These bearings are placed between the structure and its foundation. They are typically made up of material like steel, lead, or neoprene, which have an ability to deform and absorb the energy. Next is sliding moment. During an earthquake, when the ground shakes, the base isolators allow the structure to move back and forth. This sliding motion effectively isolates the structure from the intense ground motion, reducing the transmission of energy from the ground to the structure. Next is energy dissipation. As the structure moves, the energy from the seismic waves is absorbed and dissipated by the deformation of these bearings. This process helps to dissipate the energy that would otherwise be transmitted directly to the structure and harming the structure, which significantly reduce the potential damage. Next is restoring force. After the earthquake subsides, the base isolators return the structure to its original position due to their inherent restoring capacity or the forces acting on it. This ensures that the building is brought back to its original position once the seismic event is over or the earthquake is subsided. So basically, the sliding base isolators can be differentiated in three types, which are laminated rubber bearing, lead rubber bearing, and spherical rubber bearing. So let us see what are the advantages of implementing such sliding base isolators in a building. So the first is enhanced structural resilience. The sliding base isolation system improves the building's ability to withstand seismic forces and reduce the risk of damage. Next is improved safety. Occupant safety is prioritized as the system absorbs seismic energy, reducing the impact on the structure and minimizing the structural failures. Next is preservation of the contents. Critical assets and valuable contents can be protected from the damage during an earthquake, ensuring uninterrupted operations. Next is economical benefit. By preventing or minimizing the structural damage, sliding base isolation system can significantly reduce the repair and rebuilding cost of a structure. So let us see some case studies related to this sliding base isolation system. So the first is Kobe, Japan, Roko Island Bridge. The Roko Island Bridge, located in the heart of Great Hanshin earthquake epicenter, withstood the devastating earthquake forces. The implementation of such sliding base isolators played a pivotal role in preserving the integrity of this critical transportation link. So the Roko Island Bridge, located in Japan, is a great example of such sliding base isolation system implementation, where it withstood the various earthquake of higher intensity as well as medium intensity and is functioning properly till now. So the next is San Francisco, USA. Alameda County Medical Center is also equipped with the sliding base isolation system, which was remained fully operational during the Loma Prieta earthquake. This ensured that there is uninterrupted medical services to the community at the time of the earthquake or the desired need. Hence, these base isolator systems proves to be a very effective method for dealing with or the mitigation of such earthquake. Along with the advantages, there are some limitations for this sliding base isolation system, which are potential drawbacks due to the high initial cost and maintenance requirements. As you can say that such advanced equipment or advanced technology requires a very high initial cost while constructing your earthquake resistant structure, and also maintenance of these base isolators is quite important for the proper functioning of them, as there is no probability of when an earthquake can occur. So proper maintenance of these systems is must for their effective implementation and functioning. Hence, it poses a great challenge for the widespread adoption, as because of the high initial cost and maintenance, widespread of such base isolations can be difficult for everyone to adopt in various structures. Next is space constraint. In some cases, limited spaces for the implementation of such sliding base isolation systems can be a constraint also. So, as these base isolation systems require a lot of space, there can be a problem while implementing these base isolation systems. So, as a conclusion, sliding base isolation system is an effective seismic protection technique that reduces the structural damage and enhances the occupant safety also. It has been successfully implemented in various locations or structures worldwide, including the bridges, monuments, also various historical places or historical buildings, with a noticeable case studies demonstrating an effectiveness of these base isolation systems. Also, there are various innovation and research going on for the increasing this performance of the sliding base isolation system, which will increase the functioning and adaptability of these sliding base isolation systems. So this was the basic information about the sliding base isolation system. Thank you, everyone.